Okay, so this is our first supplemental topic for Unit 2, and it's called simulations. So the first thing I want to start with is just the idea of not what a simulation is, but what is randomness. So this idea also in this particular topic begins with the concept of randomness and what that really means. And randomness means usually a nice way of saying it is like a lack of, that was terrible, a lack of a pattern. And then you could also say unpredictable events, right? And then one of the things that truly randomness has that some people kind of forget about is each outcome is equally likely. So for something to be truly random and we don't know what outcome is going to pop up, then all the possible outcomes that we could have at the end of this event would be equally likely to occur. So what we do is we run simulations. So simulations. In this class, we use random digits to model a real-world situation and answer a theoretical question. So we use random digits, so random numbers, to model real-world situations. So what I'm going to show you are the steps for simulating by hand, and then I'm going to do a little example on the next slide. Okay, so there are 4 steps for simulating by hand, which we actually use our calculators, but for a lot of this. But simulating by hand, my puppy's got something I'm sure I don't want him to have, so hold on one second. Oh, he's eating a cardboard box. We're good. Simulating by hand. Okay, so first we're going to do step 1. We're going to specify how to model the situation using equally likely random digits. Random digits. So we would literally assign numbers to specific outcomes in a scenario, which I will explain on the next slide. Okay, and then explain how to model each trial. So each trial would be each time we simulate this event occurring, okay? And then we'd run the simulation. And analyze, there we go, analyze the response variable. And then in the final step, we state our conclusion, which means we answer the actual question. So we state our conclusion or answer the question being asked. All right, let me let these crazies out back so that I can do this example on the next slide for you. So I'm just going to make something up so that we can try one together. Go ahead. All right. So let's make up an example here. We'll say, okay. Example. Suppose we wake up and play basketball. My success rate is 60%. So I make 60% of my shots. That's what that means. Okay? We take 2 shots back to back. Let's say. Back to back. What is the probability we make both? Okay, I literally just made this up. So we wake up and play basketball in the morning. Our success rate is 60%, and we are going to take 2 shots back to back. What is the probability that we make both of them? Okay? So the way that I would do this is I would go to I would choose a series of random numbers. So usually the problem would say something like, use the digits 0 through 9 to model this scenario. Wow, that's awful. Scenario. I don't know how to spell that. Oh, scenario. Okay. So, what we would say is if we have a 60% success rate, 60% is the same as 60 out of 100, and 0 through 9 is equal to 10 digits. If you lay them all out, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 digits. So instead of thinking about this as 60 out of 100, we could reduce it and say that we would want 6 out of our 10 digits to represent being successful. So that means that I would and now think about this carefully. If I start at 0, the first 6 digits would be 0 through 5. If you lay them all out, 0, 1, 2, 3, 4, 5, that's 6 numbers, equal a basket, right? I made it. And then I'd let 6 through 9, or the other numbers, mean I missed it. Okay? Then we would either be provided with values if this is a simulation, or it would be our responsibility to use a feature in our calculator that we can go over together in class, but we would be provided with an outcome. So I'm going to show you what that might look like. Oh my goodness, I keep reducing the size of this slide, and all I want it to do is be easy for me to write on, but I keep messing up. I'm sorry, guys. Hold on. For some reason, it doesn't like me this morning. So right now, we're going to, okay, so I'm going to look at, now that I've got this back, we're going to say this is the trial. This is the outcome. Lord. I don't know if you can tell that I'm zooming in and out every single 20 seconds here, but for some reason it does not want me to zoom at a normal rate. Okay, so I'm going to do 10 trials. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And my outcomes are going to be random digits from 0 through 9, okay? So I'm going to use my technology to come up with this, and I will show you in class how this would happen. So this is going to be given, okay? And it's our job to figure out the how many were made, okay, in our second column. So this is what a random digit output looks like. So this is from my calculator. So every time we took, so I'm going to highlight a couple things here, right? We took 2 shots at the basket. So every time I have an outcome, there are 2 numbers. Okay, so that's how we're going to model the trial. So look, we just decided our digits are going to be represented by 0 through 5 and 6 through 9. And then in the second step of designing our simulation, each trial is 2 digits. If we look at the way these look for 2 shots, right? So I make 2 shots each trial. And then what our goal is in step 3 of our simulation is going to be to fill out the table, right? Out the table. If the number is between 0 and 5, we made it. So now I'm going to go through the table and I'm going to figure out how many times we successfully made these shots. So to me, it's actually easiest if I cross out the numbers that mean I missed. So if I go back up here, 6 through 9 means we missed. So every time I see a 6 through 9, I'm going to cross it out in my table. So that's a 9, 7, 9 and 8, 7 and 6, and a 7 right there. And now I'm going to go through and figure out how many shots I made every morning, or every trial. So here I'd get 1, 2, 1, 2, 2, 0, 0, 2, 2, 1. Okay. And everybody always thinks that I'm finally done with this problem. But at this point, I want us to now go ahead and finally, step 4 was to answer the question. And the question being asked of us is, what is the probability we make both? So, the probability we make both is going to be the number of 2's in my number made column over the total number of trials. Because making both shots means 2, I made both. Right? So we're going to count up the number of 2's we have in that rightmost column, which is 1, 2, 3, 4, 5. And then the number of trials we had was 10. So the probability that we make both is 50%. And that's just a very made up, very quick example of how to do a simulation, and we will do more in class together for practice.